all know what a pain it is to have a power outage, right? Our lives essentially stand still and time seems to stop. What really drives our city and our lives? Where does electricity come from? I'm going to tell you about the importance of steam to our society. Electricity generated by steam jets is called thermal electric power. It works in a similar way to hydroelectric plants in that both of them are generated by water. Hydroelectricity is generated by falling water, while thermal electric power is generated by steam, or water vapor. Steam, because it's a gas, has water molecules sparsely distributed through the air. These molecules want to go as far away as possible from each other, so when they're compressed, any small opening in the container will make a jet of steam shoot out. Here's how a thermal power plant essentially works. There's one area of the plant with a series of pipes on top of a heat source. The pipes are winding, so that gives the water inside the pipes a lot of time to warm up. By the time the water has been pumped to the top of the pipes, it's hot enough to evaporate and become steam. Now the steam has no more room than the water had, so it's compressed. The pipe then leads to the turbines. Now the turbines of a steam generator are not like the ones of a hydroelectric generator. The hydro turbines have really large blades and very few blades, while a steam turbine has many more blades but smaller blades. So once the jets of steam hit the turbine fins, they spin, which spins the generator and electricity is generated. After this, the steam begins to cool down, but it's not cool enough to change back into water. And the pump that moves water back to the heat source can only pump water. To fix this problem, water from outside is brought in to cool the steam back into the water so that the pump can pump it. The outside water is now warm and we have no more use for it, so it's taken back to a nearby river, lake, or body of water and dumped there. Then the pump can move the water through the pipes again, and we repeat the cycle. Now we can talk about the heat sources of the power plants. Most power plants in Canada will use either fossil fuels or nuclear reactions. We'll first talk about fossil fuels. The most common fossil fuel used today to generate electricity is coal. This is just because it's least expensive when compared to natural gas or oil. The coal first needs to be transported to the power plant either by boat or by train, and then by truck. An issue arises because any power plant should be as close as possible to the city it's serving, so that the least amount of energy is lost while it's traveling through power lines. If the plant needs to be near cities, the coal needs to be transported long distances to the plants. If there's no coal near a power plant, the plant is usually built near a railway or waterway so that the coal can be moved easily to the plant. Then docks and piers, or train stations, need to be built to accommodate the ships and trains. Another problem that arises is the storage of coal after its arrival at the power station. There needs to be lots of open area for the coal to sit before it's used. This is because a lot of coal needs to be shipped to the power station before winter hits. Ships can't travel in the water when the water is frozen. It is then broken into small pieces so that it can burn more efficiently. This is because more surface area of the coal is exposed to allow combustion. The coal is placed into the power plant and set to burn, heating the water in the pipes above it and changing the water into pressurized steam. We can easily see the cons of this process, but there are pros too. For the corporation building the power plant, a fossil fuel plant costs much less than a hydroelectric one would. Also, there's no need for damming a river or a body of water and flooding all the land around it to build the power plant. Another advantage is the flexibility of location for coal plants. They don't have to be built near moving water, so they can be put near the city that they have to serve. Now, disadvantages of coal plants are pretty obvious, I'm sure. Firstly, burning fossil fuels creates carbon dioxide and other greenhouse gases too, and other gases also that partially account for acid rain. Greenhouse gas emissions don't just come from the plant either. They also come from the transportation processes that bring the coal to the plant, like the ships, the trains, and the trucks, which all run on fossil fuels, which all emit greenhouse gases. Of course, the plant itself needs to be built, which takes up land space, causing deforestation and the loss of habitat for many animals. Once the plant is built, the railways or docks for the ships and trains need to be built, which occupies a lot of space too. The water systems and forests are disrupted. The coal that is to supply the power plant also takes up a lot of space, so even more land needs to be cleared for this plant to function properly. Then there are the issues that arise within the power plant. After the steam has been used to power the generator, it needs to be cooled into water in order for the pump to be able to pump it into the pipes again. For this step, the water used to cool the steam returns to water systems warm, which eventually warms up the whole body of water. Then the ecosystems in the body of water get thrown off, and feeding patterns and liveliness of aquatic life and the behaviors of decomposers get thrown off too. Also, a lot of energy is wasted in this process, as you can see. The water is heated intensely into steam, then some of that energy is changed into electricity. Then the heat is taken away by the cooling water, and the water inside the pipes has to be heated again, right after all that heat was taken away and was dumped into a lake or river nearby. The nuclear reactions of a power plant happen in uranium-235 atoms. This isotope of uranium is relatively unstable, but it's still safe to use. Its instability allows it to break by nuclear fission, and it releases enormous amounts of heat to power electric generators. Inside a nuclear reactor, the uranium bundles don't actually touch the water that's going to be turned into steam. They contact pipes with heavy water. Then these pipes touch the pure water, which becomes steam. Then the steam powers the electric generator the same way the fossil fuel plants did. Now, to build a nuclear power plant, you need vast areas of land to build the actual plant and the electric stations that will direct the electric current correctly. But also you need a vacuum building. When a uranium atom splits, it releases lots of heat energy, but it also releases radiation. Usually the radiation is all contained within the walls of the building of reactors. But in case an accident occurs, the vacuum building serves to dampen the radiation with large amounts of water. Again, like the coal power plants, water is needed from the outside to cool the steam into water so that it can get pumped into the pipes again. Some advantages of nuclear plants is, again, the fact that you don't need to flood or dam an area by a body of water, and you don't need to use fossil fuels, which emit greenhouse gases. Nuclear plants also do not cost very much in the long run. Once they've been built, they work well and are known to be safe. Then there are the cons. I said earlier that nuclear plants don't cost much in the long run, but starting up a plant costs a lot of money. Workers need to be safely trained, and walls and structures within the plant need to be extremely sturdy and solid. Then one of the biggest issues is the waste management. Once the uranium atoms have reacted, they are very radioactive, and currently the only solution we have to deal with them is bury them in water bays. Then there are also other byproducts of nuclear reactions. Plutonium, cobalt, and other heavy metals are only few of them. Small amounts of radiation can also slip out of the walls of the reactors. As part of Toronto Hydro's initiatives to reduce our electricity usage, there are things called peak hours and off-peak hours. Peak hours are when electricity demand is the highest, which is usually during the day. Nuclear and hydroelectric plants provide a good steady supply of electricity throughout the day, but during the peak hours we need even more than that, so the coal plants are fired up to meet the energy demand. For us, if we use most of our electricity or use our high-power electronics during the off-peak hours, we can reduce the number of coal plants that need to run. Also, electricity costs less during off-peak hours. So do your laundry, vacuuming, and machine dishwashing during the weekends or during these hours. As citizens of Canada and the recipients of such plentiful resources, we have a responsibility to use our supplies wisely. One alternative resource is solar power. Aside from the usual solar panel, which is still good, we can also try reflecting rays of light towards a hot water boiler during the day. This will heat the water, and steam can power a turbine and a generator. This particular source does not provide very much energy, but even a small-scale model of this could help run small appliances in your home. This would also take a load off all those coal plants. I encourage all of you to take initiative in trying to reduce the number of harmful waste materials we expel into the environment. Remember that nothing comes without a price. Remember that everything we use and everything we throw away has an environmental cost and takes a toll on our planet Earth. So think before you act, and act wisely. Thank you, thank you, thank you.